We know that a continuous uniform distribution defined on the interval 3 to 11, note that's got a width of 8, which is why the height here is 1/8, would appear as shown below. How would a sample drawn from this distribution appear? We're going to try a sample of size 20. Now, if we use rand lists to say 20 from 3 to 11, let's just do it. 20, 3, 11. The problem with that is it gives us random integers, and this is a continuous distribution. So that's not what we want. On the other hand, if we just say rand list 20, it gives us 20 random numbers which are continuous, but they're between 0 and 1. So the way to get around that and make sure it's on 3 to 11 is, first of all, multiply by 8. Now if we do that, that will produce random numbers between 0 and 8. So if I want them 3 to 11, I'm just going to add 3 to that. If we look at those, they would be from 3 to 11. I'm not going to scroll all the way across. Now actually what I want to do is store those. So to do that I use this, and I'm going to store them in a variable which I'll call A. This just confirms that these 20 random numbers drawn from 3 to 11 are stored in a variable called A. So what we want to do now is draw a histogram for this data. So if I go to Menu, go into Statistics, click on List 1, and I want to change the name of that to A, and then you can see it imports the data that we want. So let's just get rid of the keyboard for a moment. Now I need to set graph, and then click here, and I've actually got histogram, xlist list 1, frequency 1, those are all set, that's perfect. Now what we now need to do, actually list 1 is not perfect. That was a problem, it's actually A. Now that's much better. So if I click here, start at 3, I'm actually going to start at 0 so we get a bit of the picture, and I'm going to do the H step as 1, and let's see what it looks like. And there we go. So this was originally from this distribution, and this looks a lot less rectangular than that. And if we go back to main, we can rerun this and get ourselves a new sample. So if I go back once again to statistics, the new sample is here, and we can redraw it and we can see it's different, but still not very rectangular. Now if we use larger samples we should get a better picture. So let's make this into 50. Now I don't recommend using large samples on your CAS calculator. This one's got the power of the computer behind it, and it could tie up your calculator for a long time if you take very large samples. So if we go here and then we'll go back into statistics, the new data is here. Let's graph that once again with 0 and 1. Does it look any more rectangular? It's probably better than it was before. What about if we did something like 200? Would that look any better? So that should all be in there. Let's go back to statistics. Let's draw it starting at 0 with a gap of 1. And definitely looks a bit more rectangular. But bear in mind, if I do another 200, it's not going to look exactly the same as this one, and that's the whole point with the variability of samples.